Work means a lot of things. People think of it as general labor, but in terms of physics, there is a specific way that work is defined, and it has to do with the way that a force vector interacts with a vector that describes some sort of, how do I say it? Usually you could think of it like the ground, but it could also be something like a rail. There's a lot of nuance there, but essentially it's a force acting along a vector. And why do you say, why is a rail a vector? Well, we'll get there when we talk about some other things later in this course as to why you can think of it that way in terms of calculus. So when we think about work, if we take just a constant force vector, it doesn't change over time, just a constant force, and we act along a vector u, but we don't act parallel to u, we act maybe at some offsetting angle. Maybe parallel, but could be some offsetting angle. If we perform that work, if we perform work with that vector along vector f along u, then the total work done is given by the dot product f dot u. So if you have the vector as in terms of components, great, and if you have u in terms of components, great, but oftentimes you have force as a magnitude and you have the vector you're going along as a magnitude, and you have the offsetting angle. So a lot of physics problems, like a physics 1 type of problem that you would do, you wouldn't describe them necessarily in vectors that way. You might describe them in terms of the magnitude of the force. So we're going to do an example like that. So I've got a wagon. It's being pulled at an angle of 20 degrees, and 65 pounds is the force. So a guy's just walking a wagon, right? He's pulling it with 65 pounds of force, and he's pulling it for 50 feet. So how do we figure out what the total work done is? Well, 50 feet is the magnitude of the vector that he's going along, right? He's pulling this wagon 50 feet. And 65 pounds is the magnitude of the force. And 20 degrees is the offsetting angle. Now, if you think about it, this is kind of interesting. If he was pulling at 90 degrees, so he was just pulling straight up all the time, the wagon wouldn't go anywhere. And that makes sense, right? That the cosine of that angle would be 90 degrees and the work done would be nothing. He would just be useless. Now, if he's pushing the wagon directly along, he's not losing any force. He would be right in line with it, but he's a little bit offset. So a little bit of his effort is going towards pulling it up. That's not really pulling it across, but not that much. So when we think about this problem, the way we would do this is to get the work. We need the magnitude of that force vector, the magnitude of the medium, that's the word I was looking for, the medium that he's going along, and the cosine of the angle. So the magnitude of that force is 65 pounds. The magnitude of the distance is 50 feet. And the angle, the offsetting angle, is cosine 20 degrees. So multiplying that out, that's 3250 cosine 20 degrees foot-pounds. Now, you may not have heard foot-pound. If you deal with like cars, they talk about like foot-pounds of torque and things like that. A lot of times in the metric system, they just use newtons. So if you hear the term foot-pounds and you hear the term newtons, I'm sorry, not newtons, Newton meters. If you hear the term Newton meters in a metric system or foot-pounds in an imperial system, they're the same type of quantity. They're just different types of units. But anyway, that's it. That's work.